Good afternoon. Today we are going to do a quick introduction to matrices. You'll do a lot more with matrices in pre-cal. This is probably the only time in this unit that we will use matrices in Algebra 2. There are some really cool things you can do with them. They are fantastic at solving systems of equations. But before we can jump into systems of equations and how to solve them with matrices, you need to know what a matrix is. So what is a matrix? Well, a matrix, here's the definition, so I won't bore you by reading it, but it's basically a collection of variables, constants that are put in brackets. They're given an uppercase name, and these different numbers can represent all sorts of wild things, and it's just a different way of representing some numbers, and we can do lots of different iterations with a matrix. Just to give you sort of a preview of what we'll eventually do. Eventually, each of these numbers would perhaps represent the quotient of a variable that would allow us to solve this system of equations. Matrices were also used during the Cold War, not the Cold War. Oh, I teach math. They were used in World War I and World War II as a way to encode secret messages that were sent amongst Allied troops. So a matrix can be described in lots of different ways. It has dimensions. And the matrix, we talk about dimensions. Dimensions are important, and it has. We always talk about it with the number of rows that it has. And if you think about a movie theater, if you're walking down towards the front of the screen, here's a row, here's a row. So this matrix has 2 rows, and it has columns. And columns are like the individual sort of aisles, if you will. And this matrix has 3 columns. So this is how we would talk about it. We would say matrix A above is a 2 by 3 matrix. The 2 representing rows and the 3 representing columns. Think of it this way. You always have to go to the correct row before you can get to your correct seat. So we always list the rows first. Don't ask me why there's a white line across the video. It's beyond me. Okay, so let's talk about some other things that we can do. We can add and subtract matrices, which is kind of cool. I like this one because it's just pretty easy, and occasionally it's nice to do something easy in Algebra 2. So the first thing you have to do is you have to check 2 matrices to make sure that they have the same dimensions before you can add them. Right, so the above matrix could be added to any other matrix that was also a 2 by 3 matrix. Adding and subtracting matrices is done by adding or subtracting the entries from each matrix to create a new matrix. The sums, or we'll call it sums, differences, sort of the answers, are placed in the same corresponding position. And if you remember back to geometry, that means that they're in the same relative position. So if you're the top left number, your answer for adding a bunch of matrices would go in the top left. And we put them in a new matrix. It's commutative, so the order that you add things does not matter, but subtraction is not commutative, so order does matter. If we just look at a couple of examples, we can see ways to do this. I would add, if I was going to add, let's see, matrix A plus C, and this is the way we would write an addition statement. Capital A represents matrix A, capital C. First thing I'm going to do is I'm going to check their dimensions, and this one has 1, 2, 3 rows by 2 columns. This is a 3 by 2, and this is also a 3 by 2. So I can add and subtract any combination of these matrices. I'll do one for you. I'm actually not even going to do the whole thing. I'm going to get a resulting matrix that is also going to be a 3 by 2, and I take the first number in matrix A and add it to the first number in matrix B, and that would give me 528. I could take the second number and add 325 and add it to 90. Oh, and that's going to make my brain hurt. 2, 9, 11, carry my 1. I hope that's 415. Doing math in my head sometimes is a challenge. I move on to the next row. 383 plus 125 is going to give me an 8, 2, 10, carry my 1, 4, 5, 508. And you would just continue to do that until the matrix is completely full. Subtraction works a little bit works the same way, the same concept, but order totally matters. So to subtract, I start with B and I subtract an A value. So I would start with 120 and subtract 408. And for that particular calculation, I'm not going to rely on my brain. I'm going to tell you that it's 288. I do the same thing for the next entry. 90 minus 325 would give me negative 235, and so on and so forth. When I say that the order completely matters, it does, and here's an example of that. If I subtract A from B, then this time I'm taking 408 and I'm subtracting 120, and that gives me a positive 288. And so you can see there's a marked difference. I'd rather have $288 than to owe $288. So order completely matters. If I want to, I can move my paper. If I want to, I can do scalar multiplication. And that's just taking a number and multiplying every single thing in the array, or everything in your matrix, by whatever that number might be. The dimensions do not change. All the entries grow proportionally, either getting larger or smaller, and you can multiply each entry of the matrix by that number. So if I take the matrix from up above, the A matrix, and I multiply everything by 2, I get a new matrix that is also going to be a 3 by 2. And I do this by just taking 408 and multiplying it by 2, which gives me 816. I take 325, multiply it by 2, and I get 650. So that's the way scalar multiplication works. You can multiply by a fractional number or by a decimal. You can even do the multiplication on 2 different matrices and then subtract their resulting matrix and come up with a final answer. So there's all sorts of just kind of normalish things that you can do with a matrix. Okay, so in addition to just multiplying a matrix by a constant, we can also multiply 2 matrices by each other. So I can multiply them. There are a lot of constraints on this though. So I can multiply them only if the number of columns in the first matrix, and if I look at this matrix, the number of columns, let's see, I'm going to use orange. The number of columns would be 1, 2, 3. This has 3 columns. I'm going to put a C for columns. I can multiply it by a second matrix if this number, 3, is equal to the number of rows in the second matrix. And so this matrix has 1, 2, 3, has 3 rows, so yes, I can multiply. A lot of times people will just go ahead and write out the dimensions. This is a 2-row by 3 matrix. This matrix has 1, 2, 3 rows and 1 column. So it's a 3 by 1 matrix. And if your 2 numbers here, if they match, then you know you're good to multiply. If they do not match, then you would not be able to multiply. This is the resulting matrix that you get, and it's a little quirky, it's a little strange. It actually involves doing three different multiplication, coming up with 3 different products, and then taking the total of them, summing them. And then again, for the second row, I will straight up tell you that this is a pain in the patella to do. So I'm going to show you a different way that will do exactly this for you, but it uses a technology component instead of doing it by hand, and is so much better. Before we jump into that, that calculator activity, I'm going to first just let us practice. So I want to find the dimensions of this first matrix, and I'm going to say that this matrix has, this is not very consistent, but I'm going to, it has 1, 2, 3 rows, and it has 1, 2, 3 columns. So this is a 3 by 3 matrix. And then if I look at this one, I'm going to look at the number of rows, and the number of rows here is 2 rows, and it has 3 columns. So this is a 2 by 3. So I actually cannot multiply D times, oh, here, there was space to do it here. 3 by 3, and this was a 2 by 3. So I cannot multiply. I could not do, I can't do D times, I don't know what, times E. That absolutely will not work because the dimensions are not the same. However, I probably could, here's some examples of ones where I could. So if D is a 3 by 3 and B is a 2 by 3, they can't be multiplied. So no, can't do that. But if I look at this one, if I multiply B, and I could even have changed this to be D, B times D would work because these two inner numbers, the number of columns is equal to the number of rows when done this way. So it's weird because multiplication is not commutative, and that is not what we are accustomed to. Order matters, and switching the order can sometimes make a problem attainable that would not be otherwise. Okay, as promised, let's learn how to use a calculator to do that multiplication for us. Okay, what I'm showing you here are the steps that you need to go through to put a matrix into your calculator. So if you want to screenshot this or pause the video and practice, that's a great idea. I'm going to walk you through how to do it on an actual calculator, but I wanted you to see the enumerated steps. So take a moment, pause the video, see if you can try it on your own, and then we'll do a version together. All right, so I pulled out my calculator, 83. This is an 84. An 83 will have slightly different looking entry points, but the general idea will be this. I'm going to try to move this so you can actually see. See, that line moved again. I don't know why it's there. Oh, so many lines. I really don't want. There. Dang it. I had it. Whew, there we go. No lines. Love it. Okay, so the first thing I want to do is I just want to clear my memory because I don't know what the person who had this calculator before me actually had going on. So there, I have a clear screen. So the first thing I want to do is I'm going to actually put a matrix into my calculator. And to do that, I notice that right over that goofy button, okay, there we go. Right here is the word matrix. And to get to anything that is in an alternate color, I need to use the second key. It may be yellow, it may be blue, whatever the case may be. So I'm going to do second and type the matrix button. And it's going to allow me to either enter the names or to name some matrices, or it's going to let me do some math using the matrices, or it could let me edit them. So I want to actually edit because I don't have any matrices in here yet. I know that because once I have some matrices listed in here, it will tell me what the dimensions are. So we're going to go over to edit, and I'm going to hit enter. And then it tells me that in matrix A, it's going to create a matrix, and I get to tell it what the dimensions are. So I'm going to use matrix D, and I'm going to enter a 3 by 3 matrix. So I just hit 3 and enter and 3 and enter. And notice it creates a matrix in the window that should look like a 3 by 3 matrix. And from here, it's just a matter of typing in the numbers. So you see down at the bottom, it says 1, 1. So that's in the first row, first column. I'm going to put the number 2. The first row, second column of 5. And typically my students whine and fuss when they first start doing this because they're like, oh, do I really have to enter all these numbers? Yeah, you really do. But you'll see that it's, especially if you're going to use the same matrices over and over again, it becomes pretty handy to have them. You go through the motions, you enter them once, and then you can do other cool stuff with them. All right, so my matrix is completely entered. And now if I want to, I can do second quit, and that takes me back to the normal home screen. And this time, if I do second matrix, you'll notice that it shows me that I have entered a 3 by 3 matrix and that I'm calling it A. Let's just go to edit. There we go. So once I'm in edit, then I can move down to B. Order of operations problem. Okay, so my second matrix that I'm going to enter is matrix E. And this matrix we said was a 2 by 3. So this is where knowing your dimensions is handy. I'm going to enter the parts of this matrix. Once it's in, I like to check. So I'm going to do my second matrix. Nope, Palmer, second matrix. There we go. And I have a 2 by 3 entered into matrix B. So now what can I do with these things? Well, I'm going to do second quit again so I can go to my home screen. And I want to just pull up the name of one of them. So I'm going to go to second, I'm going to try matrix, second matrix, not matrix second. Okay, and I'm going to choose matrix, let's see, we said that I cannot do D times E. So I'm going to try doing E times D. Or actually, let's just go crazy and add these first, right? So I'm going to take matrix A, and notice it puts it in the home screen. And if I want to, I can add it to second matrix. I'm going to choose the second one, or you can arrow down and select it this way. And you can see it's going to add A plus B, which it can't do because they don't have the same dimensions. I knew that. Let's multiply second matrix B, because that was the order that I could actually do it, times second matrix A. And it does matrix multiplication that we talked about and that I showed you a formula for up above. The calculator does that for us, which is pretty handy to have. I have a bunch of other examples and problems that you can practice working on. If I wanted to, I could do second and then do my matrix A, and it's going to do some scalar multiplication. So I can do that. I could enter another matrix, second matrix, go over to edit, try a third one. And this one I want to be a 3 by 3, so I can show you some adding and subtracting. And I'm just making up some numbers here. They do not have to always be whole numbers. They can be anything your heart desires. There we go. I have a silly matrix in here. And now if I want to, I can do adding and subtracting. So if I do second matrix A, I can add it to second. And then let's see, let's 0.8. This is going to give us some ridiculous numbers, I hope. And you can see that you get all sorts of cool uses out of this. And so there's lots of things that we can do to manipulate matrices. We'll use this later when we solve systems of equations. Until then, practicing just because it's kind of fun. See you then.